Guys, today we're going to talk very briefly about translating between words, equations, tables, and graphs. And we're continuing to work on this idea of how can you use numbers and symbols to represent mathematical ideas. And in this lesson, we are going to learn how to use multiple representations to represent relations. And that would be the tables, graphs, equations, and words. And we're going to translate among different verbal, tabular, graphical, and algebraic expressions of relations. And in order to continue with this lesson, you first need to know what an equation is. An equation is just a balance showing that two sides of an equal sign are in fact representative of the same value. So let's first talk about making a table, which we did a little earlier in this um, unit. But let's look at this problem. In a game of What's My Rule, Kina picked the card shown at the right. Make a table of 4 different domain values, so it could be any domain values, and write an algebraic expression for the rule. Then state the domain and range of the relation. And if you recall, domain just means all the x values, and range would be the set of all y values. So let's look at this problem. What's my rule? Double a number, then add 3. So let's think about that. I take a number, I need to double it, which means I'm going to multiply it by 2 and then add 3. So I'm actually going to have 2x or 2n plus 3. So here's my domain. And again, it just says to choose 4 different domain values. So you can pick any domain values you'd like. I like to choose 1, 2, 3, 4 just because 1, I can see a pattern that way because those domain values all go in a row. And 2, they're easy numbers to work with. So if I'm just looking for a relation here, it's easy to, I want to pick the easiest numbers that I can to make that work. So we create the table. We put the rule in an algebraic expression form. I've chosen my domain or my x values that I'm going to use. And now I need to just simply substitute and evaluate my expression. So step 2 then would be to use the rule. Double a number, then add 3. So as we said, that translates into 2x plus 3. And I'm going to use that to find my range values. So I start with 1. I substitute 1 for x. 2 times 1 plus 3. I get 5. I do the same thing with 2. 2 times 2 plus 3. That gives you 7. 3 then gets substituted into my expression. 2 times 3 plus 3 gives you 9. And finally 4, 2 times 4 plus 3, that's 11. So once I've done that, now I have nice and neat in these columns my domain and my range. So my domain being 1, 2, 3, 4, and my range being 5, 7, 9, 11. So let's look at these 4 different, because we really kind of used almost all of these. Words is just basically when you get a problem. Distance is equal to 60 miles per hour times the number of hours. So distance, which is d, equals 60, because 60 miles per hour, times t, the number of hours that we don't know. So I've taken these words, I've translated into an equation. It's very similar to translating a algebraic expression from words to expression. The only difference is you're going to have this word is, and that is going to represent your equal sign. And whatever that is, in this case the distance, is going to go on the opposite side of the equal sign as the algebraic expression, which you can create from the words in this problem. Then I can take that and make a table. And again, you're very, when we're working with these equations with two variables here, or algebraic expressions even, you're very free to choose whatever domain you'd like. So again, 1, 2, 3, 4, those are easy numbers to choose. Plug it into the equation. 1 times 60 is 60. That's my distance. 60 times 2 is 120. There's my distance for when h is 2. Plug it in for 3. 60 times 3 is 180. So there you go. That would be your next range value. Plug in 4. 60 times 4 is 240, and that gives you your final range value. And once you've done that, you simply take domain being your x, range being your y, and you graph them. So once you plot all your points, like we talked about in our last unit, we see here in this particular case, it appears to make a straight line. And that would be the relationship that's formed here. So let's look at one last example, a STEM example. The navigation message from a satellite to a GPS in an airplane is sent once every 12 minutes. So you're going to A, write an equation to find the number of messages sent in any number of minutes, and then B, make a table to find the number of messages sent in 120, 180, 240, and 300 minutes. And then finally, you're going to graph those ordered pairs. So what do we need to do? Well, first let's take the words out of the problem to make an equation. The navigation message, the navigation message from a satellite to a GPS in an airplane is sent once every 12 minutes. So every 12 minutes, we're going to send a message. So let's write an equation to do that, to find the number of messages. So let's let t represent the time, which would be how often those 12 minutes, or the time, however long it the message from the satellite takes. N represents the number of messages that we will receive, and it's happening once every 12 minutes. So we're going to have N, the number of messages, equals the total time that we're working through this problem, divided by 12. So we have some times that were given: 120 minutes, 180 minutes, 240 minutes, and 300 minutes. That can be interchanged. In this case, we don't get to pick our range values because it's given in the problem, and that happens sometimes. So you would make a table. Fill in your range values that are given in the problem. Look at the algebraic expression portion, or the half of the equation that has an algebraic expression in it, and substitute and evaluate. 120 divided by 12 is 10. 10 would be our N, or number of messages. This also represents our range values. So plug in 180. 180 divided by 12 is 15. That'd be 15 messages in 180 minutes. 240 minutes. 240 divided by 12 equals 20. 20 messages would be sent in 240 minutes. Plug in 300. 300 divided by 12 is 25. And so there you have a whole set of, you've taken all of your range values and you've created a whole set of domain values. So now we need to graph it. And that's simple. You just draw your x and y axis. The range goes on the x-axis. In this case, it's time. And as we've talked about in class, it will very rarely not be time. It's always going to be time in almost every case of when you're graphing two variables, time being one of them. And then the second variable that we would have here, our dependent variable, is messages, and that goes on the y-axis. As always, you need to use a scale in both cases, and then you can graph your points. So that's it for our lesson. You can go back and watch any portion of this lesson as many times as you need to, but don't forget to WSQ in your notes. And just as we've been doing throughout this entire unit, all of your work can be found on the unit guide. Choose 2 problems from the problem solving practice and 2 from the skill practice, and you can check them with the key.